In any case, the yes, the WICTI project. Oh, how to make that disappear? This. Oh, there it is. Mouse. There we go. There we go. Okay. Like I said, sponsored by NOAA Project Special Merit, worked with Jim Giuliano, the State Geographic Information Officer on this. And really the goal here was to help assist with flood mitigation planning with a special emphasis on culverts and culvert data collection in kind of what I call the North Shore, so the 4 counties bordering Lake Michigan. So we did a bunch of workshops and helped develop best practices for culvert data collection, worked with local, state, and federal agencies on this. And then ultimately we created an inventory of all the culvert data we could collect. Eventually, this became a statewide layer with something like 250 or 300,000 culverts in it from 30 or 40 different partners that we worked with. This is available on our website if you're interested in culverts. You can go to this website and explore them. You can download data that we have here and use it. Most of the culverts that we collected have a limited set of attributes associated with them. I mean, the real use of culvert data, right, is primarily for things like flood mitigation planning. They're used to develop cut lines for hydro enforcement and DEM, so you can flow water through the network properly. So those are really some of the uses of culverts. We're also developing a culvert vulnerability model where we are tying culvert parameters like the size of the culvert and its composition and its slope and so on back to U.S. Geological Survey stream stats estimates of discharge from the basin upstream of the culvert to try to determine kind of at a planning level which culverts would be potentially impacted or sort of like over capacity for a particular annual exceedance probability event. Like, is it a 50-year flood or a 100-year flood? When would that culvert potentially start to fail? So that's another kind of application that we're using or that we're thinking of for, or that we're working on, not just thinking of for the culvert data. Okay, so that's one of the quick projects. A second project, this one might even be a little bit more brief summary, but we have just completed a project with the Red Cliff Water Resource Program. This project was supported by a Wisconsin Idea Endowment grant from the University of Wisconsin-Madison. So it's really a cooperative project with Red Cliff's Water Resource Program. And we wanted to help them. As you can imagine, they're rather understaffed and underfunded when it comes to the positions in their environmental department. So we're assisting them to augment their collection of hydrographic GIS data. So we constructed some hydro-enforced DEMs for them by identifying culverts and then burning those into the DEMs. We helped to derive drainage networks once those culverts were identified. We also helped define catchment areas and things like that. In addition, Red Cliff's very interested in non-point source pollution modeling. So we developed a couple of fairly easy lift non-point source pollution models that they could implement, and then did training and visited a couple of times to kind of do some outreach and training and explain how the models work. So that was an interesting project. We don't have anything further lined up with Red Cliff at this moment, but we're hopeful that we can do more. Okay, so project number 3, this one I'm going to go into a little bit more detail. And some of you will have seen this project before, but I do want to emphasize it because I think it has some particularly interesting aspects to it. So this was the so-called Ashland County Building Inventory Project. And the goal here was to develop a detailed building inventory to, again, assist in flood preparation planning. So the issue is really that if you want to use a a flood model like HAZUS or a similar model that tries to predict what the economic and human consequences are of a flood without a detailed building inventory. All that you can really use is census data. And particularly in rural areas, census data is extremely coarse at spatial resolution, right? A census tract or even a census block might be a square mile in size. There might be one building on there. Well, the population is at the building. It's not, distributed around that. So the implications are that you need to understand where the people are and where the buildings are in order to really understand the effects of the flood. Our study area was the northern 8 municipalities of Ashland County, 2 cities, or 1 city and 1 village, I guess, and 6 towns. An area that's had fairly recent experiences with high flood events with probability of more events occurring in the upcoming future, about 12,000 buildings in the area. So how did we plan to do this detailed building inventory? Well, our naive assumption, and actually it wasn't completely naive because it was based on some pilot studies that we had done a few years earlier, but the idea was to use a combination of county level building footprint data and local level tax assessment data. So the utility of the building footprints is, I guess, fairly obvious, right? These are typically derived from aerial photography, maybe from LiDAR, and they show where the buildings are, right? Most counties have them across the state. Many counties update them and keep them fairly current. There are some problems with them. I think I might mention that in the next slide, but it's a fairly straightforward kind of data product to use, and it's available. But the real key to this is the assessment data. And assessment data in Wisconsin is done at a local level, which means that every one of Wisconsin's, 1,700, is that right? Municipalities can potentially hire a different assessment company to do their assessment data. And those people can use, I don't know, whatever software or not software that they want. They might be recording it on a piece of paper in a shoebox, So there's no, unlike almost every other state, there's no county roll-up of data, of assessment data. There's no statewide collection of detailed assessment data. We're talking about, right, very specific information here at the individual building level. Things like, does this building have a basement or not? When was it built? What's its construction material? What's its occupancy type? Et cetera, et cetera. Those are the kind of things you need to do an accurate flood mitigation planning. So when it comes to assessment data, there are a couple of different scenarios that could occur. One of them is when you call the assessor at the municipality X, they might say, sure, we can give you a bunch of PDFs, 1 PDF per property. And this is an example of what such a PDF might look like. So the assessor delivers a whole bunch of these to you. And I should add that there was a fairly famous case that goes back about 20 years or maybe more, called the wire data case, which basically stipulated that if assessors deliver data in PDF format, that satisfies the so-called electronic records requirement, right, from the open records laws. This is public data, remember. This is data that is collected with using public funds to support the assessment process. Okay, but it's okay if assessors just give you a bunch of PDFs, even if the data is recorded electronically. That's okay as far as the Wisconsin Supreme Court goes. There will be a cost associated with this. It kind of depends. The assessor might charge you whatever they think is reasonable. You might pay a few $100s, something like that. There's typically no restrictions on this use of these PDFs or any data that you can scrape from them if you can figure out how to do that. But the problem is exactly that. It's actually quite difficult to extract usable data from these PDFs because the formats are variable, and not just from municipality to municipality, but within a given municipality, because some properties have a building on them, some properties have 3 outbuildings on them, and there's many other variants which just make it more and more difficult to extract data automatically from a PDF, without like cutting and pasting each one individually. So there's the cost associated with this situation. This all assumes, of course, that the assessor, the local assessor who's giving you these PDFs is using a CAMA software, computer assisted mass appraisal software, that actually supports PDF generation. Some do, some don't. If they don't, you may be out of luck. Okay, interesting slide. 80%, I think it actually has gone up since we created this map a couple of years ago, but about 80% of the municipalities in Wisconsin use something called Market Drive, which is a piece of CAMA software that is produced by a company and distributed primarily in Wisconsin, but to some other states as well. Okay, so just remember this name, Market Drive, as we move on. So assessment data, option 2. I want digital data, right? The screenshot is like XML data, but I'll take anything other than a PDF, please, because I need to put this into my GIS and I need to join this to my building footprint polygons and get what I need. It turns out that at least for companies like, or software like Market Drive and other commercial software who market their software in these types of situations, that when you ask for digital data, in their mind, it stopped being a request for public data. It stopped being an open data request, and it's become a request for their proprietary product, which they maintain and which is in their own data format, and which they feel that they don't really need to give to you. And in fact, per the wire record case, they don't. In fact, the assessor isn't really under an obligation to do this. The Market Drive or whatever software company isn't really under an obligation to do this. It gets kind of complicated too, because often, particularly a small municipality, will not have the capability, even if they're using Market Drive or other. I'm not totally trying to pick on Market Drive, but just because they're such a big player in Wisconsin. Some smaller municipalities might not have the version of Market Drive that would allow them to generate this data, so they need to send their data to Market Drive, who then generate the XML file and give it back to the assessor. So it gets complicated and it gets expensive, and typically they'll charge you per record, 50 or 60 cents a record. So okay, so 50 cents times 12,000 records in this small study area. You can see that the cost of this pretty quickly adds up, and of course that's just a snapshot, right? That's just one cut of data. It's not like you're buying a service from them. They're going to give you the latest version, and if you want next year to update that, you're going to have to pay again. They also will place restrictions on redistribution. So, in short, acquiring usable assessment data for any purpose, we're talking about flood risk, modeling here, may require significant funds. I should also add, and in fact, I think that when we started this project, the Land Information Office here, and Scott and Carmen helped us to identify some other uses for this type of assessment data. We talked about flood risk as being one of those, and that was our interest, but certainly there are many other county government functions like zoning and enforcement and tax increases and tax inconsistencies that can also be pulled from this data if we only had it, right? Even things like first responder structure specific information, if there's an incident happening, it would be useful to know the characteristics of the building that they're going into. Insurance, socioeconomic analysis, you name it. There's probably an application for this data. So it's kind of I'm just checking my time here. Kind of a tragedy in the sense that at this point, there really isn't a solution to the problem. There is a working group that has been formed. Jim Giuliano, the State Geographic Information Officer at WLIP, the Land Information Program, which is at the Department of Administration in Madison, is kind of heading up a working group that now has probably a dozen people on it, some folks from counties, people from the DOA, other state agencies, UW people like us, who are kind of trying to brainstorm ways that this problem could be solved. Are there ways that we can, figure out how to get this data that's not going to require people to provide such a huge, or initial cost to acquire it at the beginning. And we haven't come up with anything yet, but there are lots of ideas floating around. If you're interested in this topic, if you think that there's something out there in the assessor data that may be of use to you in your job, and you want to get involved in this group, just send me an email and we'll include you. We meet every couple of months and just sort of talk about ideas. So, okay. So that is that project. So we got 8 minutes. We got one more to go. Looks like I might make it. The final one here is an update on the SEO projects for the Lake Superior NER, the National Estuary and Research Reserve and St. Louis River. And Mike knows about this stuff because he's on the Friends of the NER. And I think he's knows quite a bit of this, but others of you might not. So the Ellis NER is Lake Superior NER. It is one of 2 of the 36 NERs in the country that is on the freshwater ecosystem. There is a new NER that's going to be established in the Bay of Green Bay sometime, I think, within the next few years. So there'll be 2 in Wisconsin. The other freshwater one is in Ohio. So we're special here. So this is primarily this work has been a collaboration with Kirsten Rude. Some of you might know Kirsten. She's the stewardship coordinator at the Ellis NER. We've also worked with students and staff at Fond du Lac Tribal and Community College, also UW Superior, Duluth, people at Twin Cities, and others. So there are really 3 projects. One of them was last year, the habitat map workflow. So what we're trying to do here is basically implement a remote sensing workflow to create a habitat map of the NER. This is something that's required of them by NOAA, who is their sort of overlord, and they don't have the resources in-house at the NER to do this. So they needed help. So here's the SCO kind of, jumping in to try to assist. So this started out as a 1-year project and it's turned into a 3-year project. So we started out by last year doing a workflow development process. This summer we did field data collection for the habitat map. Those were both sponsored by UW-Madison, different divisions of UW-Madison. And then starting in October, except if there's a shutdown at the end of the month, we will be starting on our 3rd part of the project, which is to map the estuary, St. Louis River estuary on both sides, Minnesota and Wisconsin, up to about a 1-mile buffer using the same classification system. And this was sponsored by the NERS Science Collaborative. So that was a federal grant. Okay, a little bit of background here, and I'll just kind of go through quickly because I don't have a huge amount of time. But as I said, NOAA requires the NERS to develop a habitat map, and it's supposed to be updated every 5 to 10 years. The NER, the Ellis NER in around Superior is about 17,000 acres. There are no standardized mapping methods identified by NOAA to do this classification. They just say you need to sort of figure it out. So what are some of the characteristics of it? First of all, it's based on the NER classification scheme, which is a very, what am I trying to say, hierarchical detailed classification system that starts out at a broad system level, things like, is it a lake or a river system or a wetland system, and goes down through a subsystem and a class and a subclass level. Primarily what we're trying to do is map the NER at the class level, with a few areas that have been identified as priority habitats by the NER that we're going to do to the subclass level. Okay, but this is a deeper classification system than something like CCAP or the National Land Cover data set, because it is hierarchical, and because at the deepest level, like class and subclass, these are some very specific types of ecosystems that you're trying to identify. So here's our field work from last summer when we did the workflow. So these are some students from UW-Madison and Fond du Lac Tribal and Community College. Those of you who know Carl Sack, that's him with the kind of orange cap on, and we were kind of playing around with the drone that Carl had access to. Didn't really use it specifically in 2022, but explored it a little bit. So we developed a workflow, it's kind of a standard remote sensing workflow to, identify training areas and then apply the classification methods to those to produce a classified map. It looks kind of complicated, but it's pretty straightforward. Okay, so what makes this project special? There's a couple of things. One is that, we all know about multispectral imagery, right? The kind of slide that's in the middle there. That's what we're dealing with. We're using NAEP imagery to do this classification because it's widely available, because it's free, because it's potentially multi-temporal over 3 or 4 year time frame, and because NOAA suggested strongly that we use that data rather than trying to use like a commercial satellite. So we're dealing with like 4 spectral bands. Okay, nothing too magical about that. You know that the core of classification in remote sensing is things look different in different spectral bands. And that's how we classify things, right? It's kind of the whole magic boiled down to one sentence. Things reflect electromagnetic energy differently in different parts of the electromagnetic spectrum. That's how we identify them, and that's how we classify. The LS NER, actually the NERS classification system presents a couple of challenges. One is that in some ways, some of the classes and subclasses that are identified that we need to find on the ground in order to satisfy the NOAA requirements are more like land use than land cover. So for example, the classification differentiates between grassland on the one hand and managed grassland on the other, like somebody's backyard lawn. Okay, those spectrally are going to look very similar to each other, but they are in different classes and subclasses in the LS NERS, or in the NERS classification system as a function of land use. Likewise, some parts of the bottom of the estuary would be classified as cultural features because they are dredged channels, and therefore they're cultural features. Okay, you can't see that on imagery. You have to use ancillary data to try to do that. So that's one challenge. The other one is that it's a very high resolution map that's required to be produced. 2 minutes. 1 meter imagery. 1 meter, a 1 meter spatial resolution map. Okay, which is certainly feasible given the fact that NAEP has about 0.67 meters. It's about 2 feet. It's pixel. The problem is that if you know anything about remote sensing, the problem is that what this kind of sidesteps is the whole fact that most of the classes we have identified traditionally using remote sensing classification methods are based on heterogeneous mixtures of stuff in pixels. So a residential land cover or a developed land cover is not a tree, and it's not a manhole cover, and it's not a piece of concrete or asphalt. It's a combination of those. But when you're at the 1 meter level, you don't have those combinations. So in my mind, I don't feel like anybody has, and maybe I shouldn't say this because I haven't like read every article that's ever been written on the topic, but I feel like this problem hasn't really been addressed adequately in the remote sensing literature, because even NOAA, for example, who are doing now a 1 meter CCAP coastal, it's their coastal classification system, are still using a very simplified classification of features that really breaks things down into one level, not a hierarchical level. And most of those are traditional land cover classes like grassland and developed and things like that. So it's a challenge. It's a problem. I don't have a solution to it yet, but okay. So I'm going to run through these images real quick. I know I'm out of time. I've pretty much said what I need to say. Here are 2003 efforts, what we did. Those of you might recognize Chris in one of those pictures. So we had two students working with us. Chris Susnick, he's in the upper, he's up here with Kirsten and Kelly, one of our consultants. And below is doing field work, standing waist deep in water. That's Emily from University of Minnesota Duluth. Okay. As I mentioned, this is 2023, so we're extending that next year through the additional grant. We're involving people from University of Minnesota Twin Cities, the spatial program, as well as folks from UW Duluth and the NRRI program. And the goal there is to do that classification for the entire estuary. Okay, so I ran through those pretty quick. I'm surprised I got through all my slides, but thanks for your time. And if you have any questions or anything like that, feel free to give me a call or send me an email. Thanks.